first page. So we have for number 1, y equals -2. For number 2, x equals -1. For number 3, m equals -1. And for number 4, m equals 5/4. Any questions on 1 through 4? Okay, 5, 6, 7, and 8. So 5 was like yes or no's. It was not multiple choice. So to actually plug them in and see yes or no. And then for 7 and 8, you needed the distance formula. In case you forget what the distance formula is, the distance formula is a variation of the Pythagorean theorem. So the distance formula is kind of like a squared plus b squared, except for a is the length between x1 and x2, and then you square it. So it's x1 minus x2 squared plus y1 minus y2 squared. I'll unzoom so you can see the whole piece. And then you take the square root of the entire piece because d squared, the distance, is kind of like the c squared. So you can totally see distance formula is a variation of Pythagorean theorem. And then down there on that page, I actually set up the distance formula for number 8. So you have 2 minus 1 squared plus 1 minus a minus 1/3, which becomes a positive 1/3 squared, all under your square root. So just to see your answers a little better. Are we good for 5 through 8? Okay. 9 and 10. So all we are doing in 9 and 10 is changing the order to solve for y. So what we're going to learn about today is increments of slope, parallel and perpendicular lines, equations of lines, and then their applications and how we can use them. So linear equations are used extensively with business and economic applications, which are a secondary side to Calc. Again, you don't have the what you'll learn, just kind of me going through it. The first thing we are going to talk about is increments, and what are they? So increments are essentially another way of saying slope or change. If a particular particle moves in a different direction, then you can look at its change in direction on the x increments and its change in direction on the y increments. Is there a reason we're not writing this in the notepad? Like, I'm seeing lots of notebook paper coming out. Like, you never should need notebook paper to take notes in my class. You can, but like the notes guides should be set up for you to do. Is increments like not at the top? Okay. I was just getting nervous. I saw like 4 notebooks come out. So the symbols delta x and delta y, these represent the difference. So in here, we're going to talk a lot about delta x and delta y. We're going to talk a lot about slope. So let's look at an example of an increment. We have the coordinates 8, 3, and negative 6, 1. So we can talk about delta x and delta y. So again, delta x is going to be the change in the x values. So that would be like negative 6 minus 8, or negative 13. And delta y will be the change in the y values. So 1 minus 3, or negative 2. Yep. Yep. Thank you. Bring my eraser tool. Okay, the next thing we want to talk about is slope. So the reason we start with the increments are because the delta line, delta x, represent the rise and run of slope. Slope is the rate of change. If a line has a positive slope, then it is the rate of increase. If a line has a negative slope, then it is the rate of decrease. We have special slopes. So you have the slope of a vertical line. A vertical line would be like the example that is in pink, where it's going straight up and down. A vertical line has a slope undefined because you get delta x equals 0, which would be the bottom of the fraction. So we know that when it comes to dividing, if you have 0 divided by a constant k, then that is okay. If you have a number in the numerator divided by 0, that is a big fat no. So 0 over a number is okay. A number over 0 is no. It's like not okay. So that's how you can see this as a hint. So this okay would be representative of a horizontal line. So you'll get a horizontal line if your slope is equal to 0 over a k. You get a vertical line if you have a number over 0. The equation of a line comes from using our key points on that line. So x-intercepts and y-intercepts are very critical points. The y-intercept in y equals mx plus b is the b number. So 0, comma b is representative of the y-intercept in y equals mx plus b form. So again, that b here matches the b in that equation because when x is 0, you're left with b. The x-intercept of a line occurs when y is 0. So that x value is kind of like our x2. We don't really know what it is. It's just an x value that occurs when our y is 0. On a graph or a line, this point over here, 0b, that's your y-intercept. And then the point down here is your x-intercept. And y equals mx plus b, you'll hear me call that slope-intercept form. Slope-intercept form. All right, so we have parallel and perpendicular lines. Parallel and perpendicular lines have key features. Parallel lines have slopes the same. Perpendicular lines have slopes opposite reciprocal of each other. So parallel lines have slopes the same. Perpendicular lines have slopes that are opposite reciprocals. So if my original slope is 2, a line parallel to that line would have a slope of 2, and a line perpendicular would have a slope of negative 1 over 2. If you struggle with parallel and perpendicular lines, there is a example problem on my YouTube from last week where I went through and walked through one, helping a student with the packet, and then just uploaded it to the YouTube. Okay, so general linear equation. For many, many, many years, our textbooks, and then all of a sudden the Calc book changes it. General linear equation, that is the same as the standard form equation. So you're going to see it and hear it called both. I'll probably typically refer to it as standard form, but especially even for like tonight in your homework, it is going to ask you for the general linear equation. If you have a standard form, the slope is always negative a divided by b. Because again, if you would rearrange that form of ax plus by equals c, you are always going to get by equals negative ax plus c all over b. So the slope of a line in standard form is always the negative a coefficient over b, and the y-intercept, or the b, is c divided by capital B. So you could look at an equation in standard form and easily know the slope just by going, okay, negative a divides b. This equation is the one we are going to use the most in Calc. This equation is the one we are going to use the most. And honestly, the handwritten version is the form I will accept. So the equation in the yellow box where they add y1 over, I consider that to be an unnecessary step and can cause algebraic errors. So if I ask you for the equation of a line and point slope form, you don't distribute the slope, you don't move over the y1. The only thing you would want to clean up is like if you had a negative, and turning them to positives. And then the equation we're the most familiar with, slope intercept, or y equals mx plus b. So again, we're very comfortable with slope intercept. By the end of this year, you are going to be comfortable with point slope. So slope intercept, it shows you your slope and your y-intercept. It is very useful when graphing. All right, so with that in mind, let's answer some of the next couple questions. It says, write the equation of a vertical and horizontal line through the point -3, 1. So a vertical line has a slope undefined. It's going to be a line that's straight up and down. So a vertical line is going to always be an x equals equation. So it's x equals -3. A horizontal line is the line that goes left to right or straight across. So if it goes through the point 8 on y, then the horizontal line has to be y equals 8. And a quick graphical representation would just be like if you had a graph and you have your point at -3. Here's the point. So if it's going straight up and down, then you can see why the x equals is -3. If it's horizontal, that's like the horizon or the sun. You can see where it goes straight across. So all your y values are 8. Okay, so let's try this next one together. So it says, write the point slope equation for the line through the given points. Well, in order to do that, we have to first find our slope. So we'll do y2 minus y1. So that gives you a negative, which turns to a positive, over x2 minus x1. So 8 plus 2 is 10. -5 minus 7 is -12. That reduces by dividing by 2. So you get 5 over -6. So it asks for point slope. So again, point slope's y minus y2 equals mx minus x2. So we have y. You pick either point. It does not matter. If I pick the first point, then it's a minus, which becomes a positive 2. My slope, x minus, and I have to use the same x value as the y value. So you could have y plus 2 equals negative 5, 6, x minus 7, or y minus 8 equals negative 5, 6, x plus 5. What? Okay, so those are both acceptable. Okay, so it says find the slope and y-intercept for the line 2x minus 3y equals 15, and then graph it. So for this problem, you can go back to the idea that in standard form, the slope is always negative a, so this case negative 2, over b, which is negative 3. So my slope is 2/3. My y-intercept is c, which is 15, over b, which is negative 3. So my y-intercept is negative 5. So the equation of my line in slope-intercept form is y equals 2/3 x minus 5. And then to graph that, you would want to show your y-intercept. So it starts at negative 5, goes up 2 over 3, up 2 over 3. And I'm hiding stuff as I'm going slow. All right, and last, determine if it is a function. So there are a couple things in order to be a function. It cannot have any repeated x's. So we're good. And then the second thing we want to do is create the equation. So it says determine m and b. So if you are on the right side of my room, which is all the boys to the right, I want you to find the slope using those 2 points right there. -1, -1, and 1, 5. You're on the left, and you're on Team Girl with Zach. You're going to find the slope using the bottom 2 points. Okay, in unison, and on the count of 3, shout out your slope. 1, 2, 3. Yeah, I should have stopped at 2. All right, so you have 2 ways now once you find your slope. So we all got a slope of 3. You can now find the rest in 2 ways. You can plug into point slope form here and solve for y. You can also plug into y equals mx plus b, pick a point from your table, plug it in for y and x, and solve for b. So again, this is method 1. So this is one method. And then this is a second method. Both are acceptable and get you to your answer. Since it says determine M and B, if you use method 2, just make sure you tell me that B is equal to 2. Because I need to know that you know what's B. All right, so a lot of what we're going to do in here is word problems. So it says a company reimburses sales representatives for their time in travel. They're given 34 cents per mile and $150 per day. So write a linear equation to represent cost in terms of x. So that's what this first line is here. C of x equals 150 because they only get that 150 per day for lodging. The x is the change in the cost based on miles driven. That 34 cents a mile is actually like 56 cents a mile today. So our textbook is from 07, so it's 13 years old. So in 13 years, it's gone up 20 cents a mile in reimbursement. Okay, and then it asks a follow-up, how much does it cost if he drives 137 miles? So what you do is plug 137 in, so you get C of 137. So this right here, that's C of 137, that's called function notation. We're going to see a lot of that. And you plug the 137 in. Hold on. I said you're going to see a lot of function notation. So to get the answer, you plug 137 in. All right, the next part. How many of you guys took stats? How many took AP stats? Almost all of you. So then the next part should be pretty easy. In stats, you guys do this a lot. You look at linear regression. So it's really helpful if you're given a lot of data. We're not going to sit and go through this problem. All the steps are on that page for you. Like, I walk you through every calculator screenshot. If you did not take stats and you need help going through this, I'll go through it with you individually. If you are totally comfortable and you're like, yeah, I can do linear regression super easy on my calculator, then you don't need to try this now. If you do not and you want to walk through it, I will walk around and help you while you follow the steps on the handout, but I'm not going to read through them to you because I think that's more confusing. But there is like a linear regression problem in your homework tonight. So again, this walks you through everything. It walks you through all the calculator buttons. That's what's there. That's what's on that screen in blue. So you go to stat, enter, put in your data. Once your data is in, you go to the home screen, hit stat, go down to option 4 for regression. If you want to put it in the y equals, you go back to y equals. Bars 5, 1. We'll put the equation in y equals. So you don't have to type it by hand. You can turn on the plots by going to stat plot and hitting enter up above on plot 1. Then you'll see your data. Zoom 9 always puts it into stat. It's zoom stat. And then you can find particular y values by using the calc feature. And we're going to go through a whole day of calculator work in here. Probably in chapter 2. So, to follow up on that, I'm not sure if the homework on the board matches what's on your paper. Go with what's on your paper. Might be like 35 or 37. It's 37. Yeah, I think I added one more based off of the AP feedback. So. We are going to now go out on our mask break.